Hello everyone, in this video we are going to learn about the first law of thermodynamics. Okay, so first law of thermodynamics deals with the law of conservation of energy. Energy can neither be created, cannot be destroyed. Means it can be converted from one form to another form. Okay, so in first law of thermodynamics, what is meant is that what is meant by this statement is that what energy goes into the system, either it should come out of the system or it should be accumulated inside the system. Okay, so the change in energy of a system is equals to the total energy entering the system minus the total energy leaving the system. Okay, so let's understand this equation with the help of one example where I'm heating water in a pan. So when I'm heating water in a pan, I'm basically transferring energy into the system. Okay, so there is some energy which I am transferring in the form of heat, that is suppose Q, or it is equals to 20 kilojoule. Okay, so in this case the energy which is going in, that is E in, is 20 kilojoule. Okay, since the water is at a higher temperature than the surrounding, it will transfer some energy to the ambient. Okay, and suppose that heat is 5 kilojoule. So the energy which is going out, E out, is 5 kilojoule. Okay, so what is change in energy of the system, that is delta E is equals to 15 kilojoule. So the energy which has, so either it will go out or it will be accumulated inside the system. So 15 kilojoule of energy will be stored in the water. So this is the meaning of this equation. Now, now the question is, how energy can be transferred in the system? What are the mechanism of energy transfer? So here in this example, I've taken heat. Okay, but the energy can be transferred using three ways. Okay, first is heat transfer, second is work transfer, and then mass transfer. So heat transfer example I just now discussed. If I take the example of work transfer, let's take piston cylinder arrangement, and here in this piston cylinder arrangement I am assuming that the wall of the cylinder is adiabatic. Okay, so there is no heat transfer involved through the wall. Okay, the heat transfer through this wall is zero, so Q is equals to 0. Now I am transferring, what I'm doing, the piston is at a particular location. Now I'm applying some force over the piston. Now piston will be moving from this location to this location. Okay, so there is a displacement of the piston and I have provided work to the system. So I have transferred some work to the system, due to which the piston has moved to some distance. Okay, suppose the work transfer, the work which I have provided is that 20 kilojoule. Okay, so in this case the E in, which is the energy which is going inside the system, is 20 kilojoule, but the energy is not going outside the system because the wall is adiabatic and there is no heat transfer involved. So whatever energy you have transferred, that energy is the energy stored in the system. So in this case again the delta E will be equals to E in minus E out, and E in is equals to 20 kilojoule, that is in the form of W in, but E out is equals to 0. Okay, now in the third case, that is mass transfer. So using mass, when a mass is transferred to the system, it carries energy with it. Okay, so let's take this previous example where you were boiling water in the pan. Okay, now when you're boiling water in the pan, you suppose you added some more mass into it, then in that case the energy has transferred to the system. Okay, now this is third way of energy transfer. Okay, so I think the difference between all three mechanism of energy transfer is clear to everyone.